just looked up at the night sky? It's beautiful, right? But it also looks like a totally random, chaotic splash of stars. For millennia, people have been trying to make sense of it all, to draw a map of the heavens. And today, we're going to uncover the surprisingly ancient origins of the very system we still use to do it.
So here's the big question, right? The one that's bugged astronomers for centuries. How in the world do you map a sky with billions of stars? Especially when everything's moving, and what you see depends completely on where you are on Earth and what time it is. It's a huge challenge.
Okay, so the modern solution we came up with is something called the equatorial coordinate system. And the best way to think about it is like a GPS for the stars. Seriously. It works by taking Earth's own grid, the equator and the poles, and just projecting it out into space. And just like that, you've got a stable, fixed map that works for everybody, no matter where they are. It's an absolutely genius tool. And that brings us to the big mystery we're diving into today. This game-changing idea, using our own planet's grid to map the entire universe. Where did it come from? Well, let me tell you, the answer is probably not what you're thinking. All right, before we get to the big reveal, we first need to really understand the problem they were trying to solve. See, there are basically two completely different ways you can look up and describe what you see. Okay, on one hand, you've got the horizon system. This is the simple, intuitive way. You just look up and say, hey, that star is low in the east. Easy, right? But that description is only useful for you right now. An hour later, it's totally wrong. And for someone in, say, Australia, it's completely useless. You can't build a real scientific catalog that way. But then you have the equatorial system. This one is universal, it's stable, and it's centered on the Earth itself. It gives every single star a permanent address, like a house number on a cosmic street. So really, one is just a fleeting glance, a personal snapshot. The other is a timeless map. It's the difference between saying it's over there and giving a precise latitude and longitude. It's a total game changer, a real revolution in thinking. Okay, so let's solve our mystery. Where did this revolutionary idea come from? Well, this idea of a stable, timeless map of the sky, it has a really early and powerful origin story in ancient China. Yeah, long before it ever became the standard in the West, Chinese astronomers had already developed and were actively using this exact polar-equatorial system. But why, though? What was driving them? Well, for ancient Chinese astronomers, this wasn't just about idle curiosity. Not at all. Mapping the sky was incredibly practical. It was totally essential for things like setting the official calendar for farmers, for regulating state rituals, and for tracking celestial events. Comets, eclipses, which were seen as omens directly tied to the emperor's right to rule. So you see, this was way more than just science for the sake of science. A better map of the sky meant you could make better predictions. That led to a more stable society, and that, in turn, meant a stronger government. It was a tool for both intellectual power and administrative power. But of course, this amazing idea didn't just stay in one part of the world. A very similar approach eventually became the absolute bedrock of Western astronomy, which led to the global standard we all use today. Yeah, this timeline really puts the whole journey into perspective. You got the system being developed and used for centuries in China, mainly for state purposes. Then, way later in the late 1500s, this astronomer named Tycho Brahe starts popularizing the method in Europe. Now, Tycho was absolutely obsessed with precision. He wanted the most accurate measurements possible, and he realized this system was the key. And from there, it leads directly to today, where this idea is the universal language of astronomy. And this quote, I think, just hits the nail on the head. A better way to organize observations can change science for centuries. It gets to the heart of the story, Sometimes the biggest breakthroughs aren't the flashy discoveries, like a new planet. Sometimes it's just creating a better method, a new way of organizing information that opens the door for everyone else. So, what's the big takeaway from all this? What does this ancient map really teach us? Well, as it turns out, quite a lot, actually. Okay, here are the big lessons, I think. First, it's a powerful reminder that great ideas come from everywhere, from all over the world, not just one place. Second, it shows that a new method, a new way of doing things, can be just as powerful as discovering a new planet. And finally, number 3, the history of science isn't some straight line. It's this rich, messy, interconnected global story.
And really, we've come full circle, haven't we? The exact same logic developed by those ancient Chinese astronomers and later championed by Tycho Brahe is baked right into the language of modern astronomy. Whenever you hear an astronomer talk about an object's right ascension and declination, well, that's just a fancy way of saying celestial longitude and latitude. They are using the direct descendants of this ancient timeless map.
Which kind of leaves us with one last thought. This whole amazing story was hidden in plain sight, right there in the coordinates we use every day to look at the stars. It really makes you wonder, doesn't it? What other secrets are just waiting to be rediscovered in the long, incredible global history of science?